Hi, everyone. My name is Isabel, and I am part of the research team here at Key Lime Interactive. I want to welcome you to our webinar, AI and ML 101, Get Started with Artificial Intelligence and Machine Learning. Key Lime Interactive is a user experience research firm that conducts both qualitative and quantitative research for Fortune 500 companies, mid to large design agencies, and government agencies. Other areas of focus are strategic, for example, persona and CJM, as well as staff augmentation. Currently, we provide full-time and part-time on-site consultants that seamlessly integrate into our clients' team. As, as artificial intelligence and machine learning become more relevant in our daily lives, it has become increasingly important for leaders in the UX field to understand how to use these tools and harness their abilities in order to further enhance the user experience. Today, our guest speaker is Carol Smith. Carol is a senior UX researcher at Uber Advanced Technologies Group. She will be discussing the ins and outs of artificial intelligence and machine learning, whether or not we should fear these new technologies, and how they are being utilized today. Before I hand it over to Carol, I want to mention that there is a chat window in the control panel in order for everyone to communicate with us. If you have any questions during the webinar, I encourage you to type them in the chat window. With that, I will turn it over to you, Carol.
Thank you. Thank you all for joining today. Should be able to see the screen now. We're going to get right into it and learn more about machine learning and artificial intelligence and what these things are. So AI is present when machines exhibit intelligence, when they can perceive their environment, and when they take actions or make decisions to maximize their chance of success at the particular goal that they're trying to do. So they have to go about this in a way that shows that they are doing these particular activities. And at their heart, they're really just a group of algorithms. Someone has determined that when this and this happen, this type of outcome is typical, and then taking that information and applying it to new problems. And they're really only knowledgeable about what they're taught. They can only control what we give them control of, and they only can continue to learn more about those particular areas. They can be aware of nuances and they can learn more, but only about the particular area that they have been trained on. And these algorithms, or cognitive computers, can do a lot of really boring things for us very efficiently, and they can do it forever. They never get tired, they never need a break. They can often make better and more consistent decisions than we do, and they can do work that we don't want to do, dangerous and deadly environments, and generally dealing with situations that are unpleasant for humans. They can translate into many different languages very, very quickly, and they can discover new connections between data that we may not have noticed because there's just so much information that we're trying to process. In the extreme, this can be found very often in sci-fi movies and TV shows, and hopefully many of you are familiar with these. There's some wonderful movies, but at the same time, they're also propagating the fears that many people have about these systems, and they're really completely inaccurate with our current technology. Cognitive computers are not conscious beings. We're in no danger of them coming to life and having feelings or emotions. They're not generally intelligent. They're not, when they first are turned on, for example, they don't have even a high school degree. They don't even have a 3-year-old's understanding of the world. They are capable of doing only one type of activity. They're not capable of doing a wide range of activities. They can really only do, again, what they were trained to do. And they're no better at understanding humans than we are. If you don't know what your neighbor is thinking, the system certainly does not either. So these are some common misnomers people have about AI. Elon Musk is unfortunately someone who tends to talk about this a lot and to propagate this idea that the machines are coming for us. And people who actually work in AI really have a healthy skepticism for this idea. The singularity is the idea that these systems will have consciousness. But it's so difficult to train these systems to do relatively small problems that we are minimally very, very far from that situation occurring. And certainly we do not need to worry about it at the level that certain individuals would have us believe. Another individual that's very famous in this area is Grady Booch. He's an IBMer, and he tells us to remember that we can unplug the machines, or they will run out of batteries. These systems are not able to survive on their own. They are simply computers, and they are doing the work that they were trained to do, and we still can change that situation if we need to and stop them from doing whatever it is that they're doing. And we've seen that happen with chatbots recently and some other incidents where people have decided that, no, this one needs to be turned off. And that is an appropriate response in many cases. So they exhibit intelligence by us transferring the human concepts we have into these systems, by us actually putting the information that we have, reams and reams of data, into the systems. And they are very dependent on those experts to be able to transition that information. So a subject matter expert like a lawyer or a machinist or a physician, any type of expert can inform these machines. They aren't themselves experts in machine learning, though, and so often they need to closely collaborate with whoever is actually creating the system. And that takes a lot of time in itself. If you can imagine trying to get the time of a lawyer or a physician to spend the time to teach a machine versus actually doing their job, it's extremely time consuming. And so the information itself has to be annotated by these experts. So they have to take the time to come up with a agreed upon understanding of a particular term, for example, and then teach the system that particular term, or at least transition that information to the engineer who is actually going to do the creation of the algorithms. And this can be done with systems. There are some systems available out there that do this. This is IBM's Watson Knowledge Studio. I've worked on this product in the past. And this one would enable you to actually identify particular items and then assign a definition to them and assign relationships between them. And so this is human teaching, supervised machine learning. And the machine is being taught this particular type of information. And this can actually be done without a computer programmer for the most part. In some cases, you'll still want that person to do some work. So this is really about the taxonomies and the ontologies coming to life. This isn't how humans learn. Humans learn through their experience. They learn through touch, through sight, through hearing. They learn about their world in a very physical and a very expansive way, whereas a computer system, needs to learn in a very narrow way about a particular topic. So they don't really learn like us at all. If you have ever seen the movie Short Circuit, this is many, many years ago, but a wonderful movie, and it actually still stands up. I saw it fairly recently again. There's a robot, number 5, and number 5 gets hit by lightning and all of a sudden becomes aware. But this wonderful scene, it starts to read the dictionary and just goes through at an incredible pace. And this is the type of thing that our cognitive systems need to do in order to absorb the amount of data that they need to know about particular topics. So it's an enormous amount of work between coordinating all the people that need to put the information in the system and then actually getting the information into the system. It just takes a lot of work. And that's because, again, we have to gather all that information together. We have to come up with a ground truth that we agree on, that the experts agree on. We have to then create those algorithms if they're not created as we're doing that work. We need to teach the system, and then we iterate, because once you've trained that system, you may notice, oh, it's learned something incorrectly, or we've changed the meaning of this, or we have a new term. And so this is a constant process, as with many things in life. I saw a quote the other day that programming is like doing dishes. You're never really done with it unless you're not going to eat again. Same with this process. You're never really done training an AI system unless you don't plan to use it anymore. So it's only as good as the data and time spent improving it, and it's always going to be biased. We are all biased humans, and the system will also be biased based on what is taught, so we need to keep that in mind as we're training these systems. Knowledge and accuracy is really something that has to be considered at the outset. So how important is the accuracy of the system for your work? And if you think about a reverse card sort, you may not be so concerned that every single individual gets everything exactly the same. And in fact, you're looking for patterns. You're not necessarily so concerned about those outliers. This is very similar to that. If you needed 100% accuracy with your reverse card sort, then you would need to think about that with regard to how you train the AI. And this differs across industries. So for example, in e-commerce, that level of accuracy may not be so important. So if you've got a lot of outliers in the clothing area, that may not be such a big deal. But as you move towards more intensive areas, so for example, safety, compliance, health, and autonomous vehicles, you start to get into an area where accuracy becomes extremely important. And that also means that a much larger amount of effort needs to be spent training the system and getting it ready to go before you're ready to say that it is trained. So let's take the healthcare example. The goal there is saving time. So for healthcare professionals to stay aware of all the different research that's going on, all the different studies that are going on, it takes approximately 160 hours a week of reading journals and documents and books to stay up to speed on their particular area. A human really can't do that and see patients and do their own work and everything else that goes into a week. And so machine learning can create more highly trained specialists. It's not an all-knowing being. This isn't someone who knows everything about every possible disease. Rather, they can be trained to learn a particular disease. And then the physician can actually select a treatment based on that patient's situation. So in this situation, the AI is not replacing the physician, but rather helping them and reducing the amount of work and increasing their effectiveness because they have the information at their fingertips rather than 2 weeks later when they have enough time to read the articles. So, for example, in sub-Saharan Africa, the cancer burden is very high. There's a lot of disease there right now. And the physicians are typically trained in 1 to 2 cancers, which is typical around the world. However, because there aren't enough of them, they're treating 10 or more cancers. And not all of those are ones that they're familiar with, or even similar to other cancers they may know. And so the patient's risk, in addition to that, of getting cancer and dying of cancer are about the same because of a lack of access to systems, treatments, and other issues. So if we can give those physicians more information about more cancers, they'll be able to more accurately treat those other patients and potentially get them the life-saving treatments that they need more quickly. So reducing that burden, how can we bring these taxonomies and ontologies to life for these individuals so that everyone can live longer? How can we broaden access to evidence-based medicine by giving them more access to more information and potentially make more informed treatment decisions with this access? So again, these are ways that these systems can add to the experience and add to the solution for people's health. And this can be used across many different industries, this type of model. So let's look at some examples of artificial intelligence. And as we go through each example, please consider, what is the intelligence needed in order to make the system work? What kind of information would you have needed to feed into that system? What is the AI perceiving in the environment or about the situation? And then what actions would it take to maximize its chance of success at the goal that it has? So strategic games. I'm sure you've heard of the famous chess versus computer game back in 1997. And then Google just in 2016 played a game of Go and was very successful in that. And you want to think about, so what kind of intelligence do they need? A lot of this is patterns. It's strategy about playing the game. Perception, where is the other player moving? What is happening on the board? And obviously these are digital boards. And then what is the action or decision that the system needs to do in order to be successful in winning this game? That's a fairly simple problem to solve, but when you think about Go, there are, I don't remember how many, but tens of thousands, if not more, of different patterns that can occur in a game of Go. It's an extremely complex game. And so thinking about all of that information and then the system still being able to determine what decisions to make is really pretty impressive. Self-driving cars. So there is a lot of information that a system would need in order to do this successfully. So thinking about, the roads, what are the conditions like? What kind of perception does that system need to be able to be successful when it's moving along the roads? And then what action or decision does it need to make in each and every stop sign, at each and every traffic light in order to successfully get people where they need to go? Image recognition. So this was a Google search I did for my cats on my Google Photos, and it picked up the cats. It also picked up a sign with an animal on it. And you can do this with your own photo applications, many of them are beginning to do image recognition in this way and be able to see patterns and recognize a particular animal and even a particular person if you tag your photos in certain ways. So this is a way that it's using the pattern itself to recognize the information in the image. Sound recognition. So labeling of bird songs. What kind of data intelligence does a system need in order to recognize a different type of bird song? And then how does it then take that information and help you make determinations based on it? So which of these bird songs just means hungry versus mating call or something like that? So thinking about those situations. And then analyzing text. This is an example of Personality Insights, which is an IBM API. And you can go on, there are many, many different types of these. These are just the ones I'm more familiar with. But if you go and put your Twitter handle in, you can get some information about yourself. And in this case, it says, I'm likely to volunteer for social causes. I like action movies. I prefer quality when buying clothes. Unlikely to, interestingly enough, picked that I don't like to attend live musical events, which is not true. So these systems don't necessarily get 100% accuracy at any given time, and they are only as good, again, as the information provided to it. At some point, I must have made a negative comment about music, and it took that to mean I don't like to attend musical events. These systems can be used to recognize healthy body parts. This is, again, pattern matching. So healthy eyes, what does a healthy eye look like? And this can lead to much quicker identification of glaucoma and other eye diseases, because if the healthy eyes, people can get their diagnosis very quickly and then go home. That's wonderful. And then the people who do have a disease can more quickly get this treatment that they need, instead of waiting for a physician to be able to examine each and every one of those scans. So this is speeding up the healthcare system a great deal. The same with repetitive work, such as looking at x-rays. Radiologists spend a lot of time looking at very healthy bones. And so if the system can identify the healthy ones and let those go home, let those individuals go about their day, and then the radiologist can spend more time on the more difficult cases and really not have to worry about the backlog of healthy limbs that are going by. Understanding human speech is something we're seeing more and more. It's on our phones, it's on our computers, it's really everywhere now, and we can use these systems to get information, to get help, to order supplies. And in this case, there are many different pieces at work in these systems. They're pretty complex. There's speech to text, there's that translation piece, there's the actual chat itself, there's all kinds of APIs working in the back end. You'll see this, you can order through Staples using their online system. They actually have corporate versions now, which are apparently getting very, very high tech, which is fun. There's Wobot. This is a behavioral health system where you can actually work with this robot to help you get to a better place mentally. It actually is a little assistant that pops up and asks you how your day is and gives you tips to be more mindful or whatever it is that you want to work through. And again, these are all automated. However, the question is, are they AI? And in a lot of cases, they're not. In most cases, they're not. So for example, my Alexa at home, I love dearly, but she can only do one thing at a time. She can only respond to specific questions with specific answers that she has in her database. She expects a certain language to be used, and she has appropriate automated responses. And at some point in many of these systems, they say, you know, you're going to need to do that search in a different place, or you need to talk to an actual human if it's a help desk type situation. So these aren't really quite at the level of AI yet, but they're getting there, and they're really cool and a lot of fun. So let's talk about ethics briefly. Again, this is Gray Booch, and he talks about how humans teach what we feel is important, and we need to teach these systems to share our values. And again, they're super knowing, but they're not super doing. They don't actually do a lot of things, and they only know a fairly narrow amount. And we just need to keep these different things in mind as we develop these. So think about, as you're building these systems, how can you build a system that has an ethical and moral foundation, and that's transparent to users, that they understand how it was made, that teaches mercy and justice of law, that extends and advances healthcare, and that increases safety in dangerous work. So these are all some big challenges for us as we move forward. In some situations, we may want these machines to be trusted as well as a human. And will we get to that point? We may. Some people may be more willing to than others. This is another area to think about. So some guiding principles as you're working through these situations are thinking about the purpose. Why an AI? Is it to aid humans, ideally, not to replace them? And how can we work through a symbiotic relationship? There will be some job losses, but at the same time, how can we make sure that we're supporting humans and making sure that we're not making that as commonplace as people fear? Transparency. How was this AI taught? What data was used? What kind of biases might be there? And how can humans remain control of the system so that they can indeed stop the system, retrain the system, fix it when it's going astray? And then skills. It needs to be built with people who are actually in the industry, from the subject matter experts. And those human workers need to know how to use the tool, how to use it to their advantage. And then the people who are using the end product need to know how to use it as well. So thinking through, how is that going to work? What kind of skills do we have available? And how can they use those skills? And again, we often have no way of knowing when and why people are biased, and we are all biased. So how do we work around that? How can we help to make as good a system as possible? Regulations are necessary. Everybody agrees on this. We need to make sure that there are rights, that people have rights and safeguards against automated decision making. And we need someone to create and enforce those regulations. Who that's going to be is in question. There are frameworks being built. So there is, in the EU, there's a system in place to contest a completely automated decision, and people have a process now to be able to do that, which is a nice first step. But these regulations really take a long time, and we need to figure out how to have them make less biased decisions, or at least be very transparent about the biases, and then make sure that the algorithms that are trained with biased data and pick those up, that we're aware of them and that it's very obvious. And we need to think about how we can evolve the practice of UX to deal with these new issues and all the challenges that these issues are going to bring about with the new information that's created, as well as the systems themselves. So I encourage you all to take responsibility, create a code of conduct for the system that you're building. Think about what you value and what lines your AI won't cross. So where is the gray area? Identify it as soon as you can, and then determine where you stand on that issue. And make your AI as transparent as possible. So make sure that people are aware of how it was made and what it does, and how you are working to reduce the bias so you can keep the humans in control. I see we have a question. What is an example of biased data when teaching an AI system? So it can be as simple as history. If you're teaching a system history, history is, of course, written by the people who survived. And certainly different people have a different idea of what that means. And even that is probably somewhat biased, a statement. So just thinking about the information that you're teaching it. There may be different ways of treating. We were talking about cancer earlier, certainly different hospitals have a different approach to treating a particular cancer. One may be more aggressive, one may be less aggressive, and knowing that and how the system is taking that information. Another example could be in the rule of law. One state may very severely penalize someone for a particular activity, whereas another state may not. And that reading of the law would be very important if you're making a law app. So any data basically can be thought of in that way, in the different ways. There's always a different angle on different types of information. And even in coding, how people in UX, so we can have a survey, and the survey questions, as we know, can be very biased and very misleading in some cases. And so those are examples as well of bias, just in the question, much less in the way people are answering. They're going to be biased in their answers as well. Okay, so don't fear AI. I really encourage you all to explore it. So try out the various tools. If you do a Google search, and there's actually a list here, I think we're going to be sharing these slides after this, with lots of links to different tools. There are many that are at least free to try, if not free completely. There's a lot of open source options out there. And if you're not comfortable with coding, definitely pair with someone who is interested in this as well, and work out some problems that you want to solve, and go for solving them. You can do this with relatively ease. They're really not many of them are complex systems, but once you understand what to do, they're not that bad. And you'll want to specifically think about your purpose. So what are you going to do? What problem are you trying to solve? And what intelligence do you need? And what actions does the system need to take to maximize success? So if you're looking for patterns, for example, in trouble tickets, from the help desk, then you know that the information that you have is the older tickets that you have, and then the system to maximize success is going to need to look for patterns throughout that data. And then transparency, make a code of conduct or ethics for your system and share that with anyone who's using the system so that they're aware of what you're trying to do and that you're aware of the biases and that you know some of the information, and if people have questions, they have a way to talk to you about those questions. And skills, think about how humans will use it, how they will work with it, how to make it as usable as possible, so that people see the power of it and are able to actually use the power, benefit from it. And this is my contact information. Feel free to get in touch, and we have time for some questions. We have about 4 minutes on my clock. Any more questions?
So it looks like, oh, there we go. Another question.
Okay, another one. Yeah, our chatbots AI. So I touched on that briefly. Most chatbots aren't at this point, mostly because they are really a question and answer type programming. It doesn't mean that there isn't one out there, but most of the ones I've interacted with are minimally AI. So the one I mentioned, the behavioral one that I mentioned a little bit earlier, that gets into AI in that it is actually looking for information and responding in a relatively independent way. So it's actually determining how to answer my question in the best possible way. So it is making a decision with the information it already has. So I would say that one probably is closer to AI. Alexa and Siri and most of the ones that we have daily interactions with are not right now because of the way they're scripted so carefully.
All right, it looks like we are all set. I would like to thank everyone for joining us today, and thank you, Carol. That was great. We will just be distributing a recording of this webinar later today. Stay tuned for updates on the next installment of our Trailblazer webinar series. And happy Tuesday from your friends at Key Lime Interactive. Thanks so much.
Happy Tuesday. Thank you.